Hi grade 12s and welcome, and in this video we'll be looking at circle theorem. Circle theorem is a topic in mathematics that you need to know even as you prepare for your grade 12 final examinations, whether it be GCE, whether it be ordinary grade 12 final examinations. And I believe this topic is learned in grade 11 or grade 12, and so to you grade 10s, to you grade 11s, you're free and welcome, and we can get into circle theorem. So we're going to first look at how to go about circle theorem and understanding circle theorem. Then later on we'll look at past examination questions on circle theorem. Okay, so we can get into circle theorem. So when we talk of circle theorem, we are really talking about angles subtended in a circle. Okay, so firstly, grade 12s, you need to be familiar with angles. So when you talk of, let's say, a triangle, when you talk of a triangle, and this triangle has three sides. Because it's a triangle, it's got three sides. It's got side A, it's got angle B, it's got angle A, angle B, and angle C. As a grade 12, you need to know to say that the sum of the angles in a triangle is always 180. So angle A plus angle B plus angle C should give you 180 degrees. So if I was to tell you to say angle A, which is this one here, is equal to 40 degrees, and angle B, which is this one here, is equal to 72 degrees, and I asked you to say what is angle C. So angle C plus angle A plus angle B is equal to 180 degrees. But we already know what angle B and angle A are, so we'll have angle C plus what is our angle A, 40 degrees, plus what is our angle B, 72 degrees. This is equal to 180 degrees. And so you can work out what angle C is. So to find angle C, we say 40 plus 72, and 40 plus 72 gives you 112. So we've got angle C plus 112 equals 180 degrees. And we can group the like terms, or rather we can subtract 112 from either side of the equal sign, and we're going to have, let me write it here, angle C is equal to 180 minus 112. Okay, so what is 180 minus 112? Angle C is therefore equal to 68 degrees. So therefore our angle C is 68 degrees. So to find, key points to remember is that angles in a triangle always add up to 180 degrees. This is a very good starting point even as we delve into circle theorem. Okay, so let's see what we can do, and let's get into circle theorem properly. So here's the circle, and this circle has a center. So every circle has got a center, and the distance from the center to the circumference of the circle, so this is known as the circumference, this whole boundary of the circle is known as the circumference. This is known as the center, which we'll label as O. And the distance from the center of the circle to the circumference is known as the radius. And since this is the center, it means that the radius, it means that the distance from the center to any part of the circumference is the same. So the radius is the same in any type of circle, or at any point of the circumference. From the center to the circumference of the circle, the radius is always the same. So if you know what radius is, then there is what is known as the diameter. When we talk of diameter, we are referring to the distance from one end of the circle, passing through the center of the circle to the opposite end of the circle. So my line hasn't reached the other end. So from one end of the circle, okay. When we talk of diameter, we're talking of the distance from one end of the circle passing through the center to the opposite end of the circle. So this distance is known as the diameter. This is known as diameter. So this is known as the diameter, and the diameter of a circle is the same through at any point passing through the center to the opposite end of the circle. So when we look at the diameter is simply made up of two radii, meaning there is this radius from this point, from the center to this end, and then there's also this distance from the center to the other end. Okay? Alright. Then what the diameter does is it divides the circle into two half circles known as semicircles. Believe you know what a semicircle is. So it divides the circle into two half circles known as semicircles. Okay. Okay, grade 12s. Then you might have another line that is not passing through the center of the circle, but is there's the center of the circle, but is moving from one end of the circle to an opposite end of the circle. This line is what is known as, let me just draw it, from one end of the circle to the opposite end of the circle. So this line divides the circle into two parts. There's this part and there's that part. And the difference between this line and the diameter is this one doesn't pass through the center of the circle, but the diameter passes through the center of the circle. So this line is what is known as a chord. This line is known as a chord. And we said a diameter divides the circle into two equal parts known as semicircles, while the chord divides the circle into parts known as segments. So this is a segment, and so is this one. Okay, so let's just have a quick recap of what we have learned so far. We've learned that this is a chord. We've learned about the radius. We've learned that this is known as a radius. We've learned about the diameter. Okay, imagine it's reaching up to the end. Let me just make it reach up to the end. Okay. We've learned that this is a diameter. And we've learned of the center of the circle. Okay, so these are really important, and we've also learned of the segment and the semicircle. Okay, so these are very, very important, and we can move on from there. So grade 12s, let's say we have a circle. Let's say we have a circle. We have a circle, so I'm trying to make them as big as I can so that they are really visible. So let's say we have this circle, and this circle has a center and it has a segment at the bottom. It has a segment at the bottom, rather a chord at the bottom. So this circle has a chord at the bottom and it has lines running from the center of the circle to the chord at the bottom. And so what shape is being formed, has been formed? When you look at it, we have a triangle inside a circle. We have a triangle inside the circle. So let's assume this is our center O. So my centers are not so accurate, but let's assume this is our center O. We have a triangle which is O, A is A, and this is B. We have a triangle OAB. Okay, and I tell you to say the first principle that we're going to look at is the one that says when you have a triangle formed in a circle and it has lines moving from the circumference of the circle to the center of the circle, lines joining at the center of the circle, and you have that triangle, the angles at the bottom, or rather at the circumference of the circle, as long as the lines at the angles at the bottom of the circle, at the bottom of the circle, at the circumference of the circle, are always equal. So if we have this angle here, angle A is always equal to angle B there at the bottom. And then this one is the one that's different, the one at the top. Okay, grade 12s. So as long as you have a triangle with lines joining at the center of the circle and coming down to the circumferences, or rather the circumference of the circle, the angles at the circumference of the circle are always equal. Is that okay? Okay. So let's assume that we've been told to say angle O is equal to 70 degrees. And I ask you to say find angle A. Find angle A. Find angle A. And put a question mark. Find angle A. So how do we find angle A? We know that angles in a triangle should add up to 180 degrees, right? So meaning we've got 70, so 70 plus angle A plus angle B should give us 180 degrees. Am I right? Yes. And then we've also we've noticed to say this triangle runs up to the center of the circle, has got lines joining at the center of the circle. So therefore, these two angles at the bottom are the same. So angle A is equal to angle B, right? So meaning where there is B we can put A, where there is A we can put B. So 70 plus angle A plus angle A is equal to 180 degrees. So why we said plus, why we have two A's is because this angle and that angle are the same. So if we say this is X, meaning this is also X. If we say this is Y, this is also Y. If we say this is angle A, this is also angle A. If we say this is angle B, this is also angle B. So we've got 70 plus A gives you 2A. So 70 plus 2 angle A equals 180 degrees. Then the 70 can go to the other side. We have 2a is equal to 180 minus 70, right? So 2a is equal to 180 minus 70 gives you a 110. Divide both sides by 2 gives you a equals 110 divided by 2 gives you 55 degrees. So our angle A is equal to 55 degrees, meaning this one is also 55 degrees. So we've got 55 there, and we have 55 on angle A. So we can remove the question mark, and we have our 55 degrees there as well. So this is a very, very important and easy concept to grasp. All you have to remember is as long as the circle, or rather the triangle formed in the circle, has two lines joining at the center of the circle, then the angles at the bottom of the circle are always equal. The angles at the bottom are always equal. The angles at the bottom of the triangle are always equal. Is that understood, grade 12s? So look at past examination questions, and we'll try to practice more, and we'll try to understand and try to have these in our memory so that we never forget. This is quite easy, it's quite straightforward. So we can move on to the next principle in circle theorem. Use white. Under this principle, when you have a circle, and this time let's forget about the center. Let's say our center is there, right? Let's say our center is there, and we have a triangle still, but in this time the triangle is not having any lines joining at the center of the circle, but instead this triangle is being formed at the circumference of the circle. Okay. Then we have another triangle being formed from the same chord, but this time at the center of the circle. Okay, this time at the center of the circle. So let's say this is our center O. And maybe we can forget about the chords. Maybe, okay, let's just leave it. So we have two triangles, right? We've got this triangle on top, and we've got this smaller triangle at the bottom, but they are both coming from the same points. They are both coming from these two points of the circle. We've got this one here, and we've got this one here, right? So what principle, what property of circle theorem do we get from that? Well, when you have two triangles, or when you have two angles that are coming from the same points, or the same part of the circle, same part of the circumference of the circle. So let me just label this as A, this is B, and this is C. So we've got O there, we've got triangle OBC, and we've got triangle ABC. The only difference between the two triangles is that this one is being formed at the center, while this one is running up to the circumference of the circle. So just by looking at those, which angle do you think is bigger between the one formed at the center of the circle, this one, and the one formed at the circumference of the circle? Which angle do you think is bigger, just by a visual inspection? Well, you find that when you look closely, you'll find that the one at the top is smaller, or the one at the bottom there is bigger. And there is a principle there's a property, a law that has to be adhered to when we're dealing with such angles. So we say the angle at the circumference is half the angle at the center. So A is equal to half of O. Angle A is equal to half of angle O. Or rather, let me write it as, so that we can see it clearly. We can say B, angle BAC is equal to half of angle BOC. Meaning, this angle at the center is twice as big as the one at the top there. So we'll say BOC, angle BOC is equal to 2 times angle BAC. Alright, so what do we mean? Let's look at a practical example. Let's look at a practical example so that you can grasp the principle and the property that we're talking about. So let's say I tell you to say this is angle 10 degrees. Then what angle is there at the bottom? Then this is definitely 20 degrees. Okay? And if I told you to say this is 45 or 40 degrees, let's make it 40. This is 40 degrees. Then this one is definitely 80 degrees. What if I told you to say this is 100 degrees? Then what angle is there on top? Then the angle there on top is simply half of this one, which is 50 degrees. Easy to understand, isn't it? So now let's look at a more integrated example, a more blended example. So we've looked at 2 principles. We've looked at one that talks about a triangle formed at the center of the circle running to the circumference, and we agreed to say the angles at the bottom at the circumference there are equal. And now we've looked at a second theory, a second principle, which says when you have 2 angles being formed at the circumference and the center respectively, the one and as long as they are coming from the same points, the one at the circumference is twice as big as the one at the center is twice as big as the one at the circumference. Okay, so now let's look at a more blended example. So what if I told you to say this is 30 degrees, and I tell you to say find angle BOC, find X. Okay, so how do you go about it? So I'm telling you to say find BOC, or rather, sorry, not BOC, find OBC. Okay, so what do we have? We've been given angle BAC. We've been given angle BAC to be 30 degrees, right? So we can find angle BOC. So if this is 30 degrees, what is BOC? So BOC is equal to 2 times BAC, right? So BOC is equal to 2. What is BAC? BAC is 30. So therefore BOC is equal to 60 degrees. So meaning we've got a 60 degrees there at the top. And from there it gets really easy to find angle OBC. So to find angle OBC, we've agreed to say as long as the triangle is coming from the center of the circle, coming to the circumference, the angles at the bottom are the same. So if this is X, it means this is also X. So we can say BOC plus X, and if this is X, it means this is also X plus X is equal to, and this is a triangle, so this is all equal to 180 degrees. And we know our BOC to be 60 plus X gives you 2x. This is equal to 180 degrees, right? Then the 60 goes to the other side. We have 2x equals 180 degrees minus 60 degrees. We have 2x equals 180 minus 60 gives you 120 divided by 2 divided by 2. And therefore, our x is 120 gives you a 60. So therefore, our x is 60 degrees. Okay, let's look at another example on the same. Let's look at another example on the same. Let's say we have a circle. Let's say we have a circle and we have a triangle being formed at the circumference. We have a chord there. Then we have the center of our circle being there. Okay, and we have another triangle being formed at the center of the circle, coming from the same point as the previous triangle. Okay, coming from the same point as the previous triangle, we have that, and then tell you to say this is 32 degrees, and then this is A, this is B, this is C, and this is O. 32 degrees, and I ask you to say find angle BAC, find x. How do we go about it? So, considering the fact that this triangle OBC is being formed at the center of a triangle, or rather we've got two lines which are meeting and at the center of a triangle, at the center of a circle rather, it means that the angles at the bottom are the same. So if this is 32 degrees, it means this is also 32 degrees. So what I'm trying to say is OBC is equal to OCB. So if this is 32 degrees, it means this is also 32 degrees. So we've got OCB to be 32 degrees. And we know that to find this angle, we simply add all the angles in this triangle and they should add up to 180 degrees. So we're going to say OBC plus OCB plus BOC is equal to 180 degrees. So this angle, that angle, and that angle should give us 180 degrees. What is our OBC? Our OBC is 32 degrees. What is our OCB? OCB, this and that are equal, so it's equal to 32 as well. And finally, what is our BOC? BOC, we do not have BOC, so we'll leave it as BOC. And this is equal to 180 degrees. Now we together get 12. So from there we can add 32 plus 32, which gives us 64. So we've got 64 degrees plus BOC is equal to 180 degrees. We add the 64, we subtract the 64 from both sides of the equation, or rather the 64 goes to the other side and changes to a negative. So we have BOC equals 180 degrees minus 64 degrees. So what is 180 minus 64? 180 minus 64 gives us 116. So we have BOC equal to 116 degrees. Have we found X? Well, let's just insert the angles that we have. So we said OCB is equal to 32, so we've got 32 there. And we found BOC to be 116. But have we found X? No. X is the one on top. And since these angles BOC and BAC are both coming from the same point of the circumference of the circle, it means that this one is twice that one. What I'm trying to say is BOC is equal to 2 times BAC. And we know our BOC to be 116 degrees. P is equal to 2 BAC. We divide both sides by 2, and that gives us 58 degrees. So we have BAC being equal to 52 degrees. And we know that BAC is simply equal to X. So X is equal to BAC, which is equal to 52 degrees. So we've got our X there to be 52 degrees. I hope we are moving together grade 12s. These are very, very easy concepts to grasp, and very, very easy topic for us to understand. And these are topics that we are supposed to maximize our marks on. And so let's try and grasp the idea and understand what's going on. So I can move on to the next property of circle theorem. And in this case, we are going to have a circle, going to have another circle. Okay, we have another circle there. Let me just draw it at the center. We have another circle, and as usual we have lines. We have let me start with drawing the center of the circle first. Let's say our center of the circle is there, is point O, and then we have our diameter, which is a line passing through the center of the circle, coming from one end of the circle, passing through the center of the circle to the opposite end. Okay, so what this diameter has done is it has given us two semicircles. It's given us two semicircles, and since we have two semicircles, we can have two triangles being formed at either end or on either semicircle. So we've got that line, and we've got this line. So what we have is a triangle that is being formed from the diameter of the circle, and we can name our triangle to have A, B, and C. So we have triangle A, B, C. Can you see that triangle, grade 12s? Okay, so if you can see that triangle, that's good. And if we have triangle A, B, and C, means that this triangle has been formed through the center. It's passing through the center, and one part of it is on one side of the semicircle. So this angle that is formed at that point of the semicircle is always 90 degrees. Are we together, grade 12s? So as long as you've got a circle and you've got a triangle being formed through the diameter of the circle, the angle opposite the diameter of the circle is always 90 degrees. So no matter where the angle is being formed at, as long as it's been formed the opposite of the diameter and the points that are forming the triangle are coming from the extreme ends of the diameter, the angle that is being formed is always 90 degrees. So we've got that, no matter where it is, this angle there at the top is always 90 degrees. Is 90 degrees as well. Can you see that? So it is 90, that's 90, that's 90. And do you know why they are all 90? Because they are all coming from that point. Those 2 points rather. So angles that are being formed from extreme ends of the diameter of a circle are always at 90 degrees, or angles that are formed in the semicircle of or in a semicircle are always 90 degrees. So it's 90 degrees, it's 90 degrees, and that's 90 degrees. Are we together, grade 12? So we can try and see how best we can understand this. So let's say we have an example which is in this form. Let's say we have an example. Let's say we have an example. Here's the center of the circle O. Then we have a triangle being formed. Okay, we have that triangle that has been formed, and I tell you to say this is angle 25 degrees. They ask you to say, grade 12, find angle X. This is triangle A, B, and C. This is triangle ABC. So find X. X is BAC. Find angle BAC. How do you go about it? Again, when we're dealing with second theorem, as long as you do not understand to say angles in a triangle add up to 180 degrees, it will be difficult for you to navigate around this topic. So we have a triangle A, we have triangle ABC, and the angles in triangle ABC should add up to 180 degrees. So we've got angle BAC, ABC, and BCA. So we've got A, B, C plus B, C, A plus B, A, C should be equal to 180 degrees, right? So do we have angle ABC? Angle ABC is a triangle, is a center of the circle, is a diameter. So this is a semicircle, this is a triangle being formed within a semicircle. So angle ABC is 90 degrees. It's the angle that is opposite the center of the circle. So this is 90 degrees. So we've got 90 degrees there. Plus, what is BCA? BCA. BCA is 25 degrees. Plus, what is BAC? BAC. BAC is X. So we've got X equals 180 degrees. Okay, Then we move on from there. What is 90 plus 25? What is 90 plus 25? 90 plus 25 gives us 115 degrees plus x equals 180 degrees. This goes to the other side. We have 180 minus 115. So we've got x alone on this side. X equals 180 minus 115. Now what is 180 minus 115? This gives us 65. So we have 65 degrees. So therefore we found the value of x to be 65 degrees. And that's how you go about this principle. Very simple principle and easy to remember. Let's look at a different principle. So the next principle that we're going to look at is one that deals with angles that are coming from the same segment. Rather, sorry, I keep on saying segment, but angles that are coming from the same chord. So let's say we've got a chord there, and we've got a triangle. This one, forget about the center of the circle. We've got a triangle there, and we've got another triangle this side. And we've got another triangle. We've got another triangle. So what do you see common about all these triangles that we have in this circle? What do you see as common? Well, what is common is that all the triangles that I have drawn are coming from the same points. Coming from the same points. So let's name these points as point X and point Y. Right? So all the triangles that we have in this circle are coming from points X and point Y. So now, for as long as they're coming from the same points, the angles at the circumference of the circle are all the same. So if this angle is there, and this angle is there, and that angle is there, and that angle is there, all these angles are coming from the same points. And as long as they're coming from the same points, all these angles are the same. So if this is angle A, this means this is angle A, this is angle A, and this is angle A. As long as they are coming from the same points. So in some cases, you might not even have a chord there at the bottom, but what you have is something looking like this. What you have is something looking like this. Going to have something looking like this, and you've got that, and you've got that. Do you see that? And I ask you to say what angle is here if this angle is 30. So when you look at this angle is coming from that point and that point, and so is this angle coming from that point and that point. Let me just highlight the points from which the angles are coming. So they're both coming from this point and this point. So therefore, if that one is 30, it means that this one is also 30 degrees. Understood, grade 12? So let's look at an example on how to go about this principle. So as I said, as soon as we are done, in the next video we'll look at past examination questions on circle theorem. And so here's just something to help us with the previous principle. Let's say you have a chord there, right? And then we have this triangle there. And I tell you to say we also have this angle there, this triangle there. Right? And I tell you to say the angle here is 85 degrees, and the angle there is 30 degrees. And this is point A, point B, point C, and point D. And I tell you to say find X. What do you think we do with 12? We have angle ABC, we've got angle ACB, and we've been asked to find angle BDC. So we can find from these two angles, we can find this angle at the top there, and this angle at the top, which is angle BAC, is simply 180 minus 30 plus 85. What I'm trying to say is this is a triangle, so the angles in this triangle should add up to 180 degrees. So we're going to have BAC plus ABC plus ACB should be equal to 180 degrees. Okay, these are angles. Angle. What is angle BAC? BAC, we do not know. We'll leave it as BAC. Plus, what is angle ABC? ABC. Angle ABC is 85 degrees. What is angle ACB? ACB is 30 degrees. And this is equal to 180 degrees. Okay, then what do we get when we say 85 plus 30? 85 plus 30 gives us 115. So we have BAC angle plus 115 degrees equals to 180 degrees. So the 115 goes to the other side. We have BAC equal to 180 minus 115 degrees. And 180 minus 115 gives us 55 degrees. So BAC is equal to 55 degrees, right? But we're not looking for BAC. What we are looking for is angle BDC. But what is common? Well, BAC and BDC are both coming from the same points, which are B and C. So we say BAC is equal to BDC. So BAC is 55 degrees, so therefore 55 degrees equals BDC, which is equal to X. So we found the value of X to be 55 degrees. And that is just us trying to grasp the principle of lines coming from the same points, or rather same points on the circumference of the circle, on the circumference of the circle. We can move on to the next property in circle theorem. And for this property has or deals with what are known as cyclic quadrilaterals. So when we talk of cyclic, we are simply talking about circular, or rather in a circle. So we have this circle, and in this circle we've got a quadrilateral. What is a quadrilateral, grade 12? A quadrilateral is simply a shape with 4 sides. Okay, So we've got a quadrilateral, okay, quadrilateral has 4 sides. So this shape that we have there qualifies to be called a quadrilateral. A cyclic quadrilateral for that matter, because it is in a circle, C and D. When you're dealing with a cyclic quadrilateral, the principle that applies to cyclic quadrilateral says that angles that are opposite each other in a cyclic quadrilateral should always add up to 180 degrees. So 180 degrees is a very big deal in this topic. So angles that are opposite each other in a cyclic quadrilateral always add up to 180 degrees. So in this case, which angles are opposite each other? We've got angle A, which is this one, opposite to angle C. Angle A plus angle C should give us 180 degrees. Angle D and angle B should give us 180 degrees because they are opposite each other. Angle D and angle B should give us 180 degrees. These are very, very important concepts, very easy to grasp. Opposite angles give you 180 degrees. So angle A plus angle C should give us 180 degrees. Angle B plus angle D should give us 180 degrees. Understood? Well, we'll look at examples, we'll look at past examination questions, and this property should be easy to understand once we get into questions, past paper questions. So it's a very, very simple, very simple concept, very simple property, very simple principle that you can understand. In a cyclic quadrilateral, as long as you've got 4 sides and these are connected at different points, got A, B, D, A and B connected at A, got A, B and C connected at B, and got C, D and A connected at D. So when you've got a cyclic quadrilateral, opposite sides should always add up to 180 degrees. Understood, grade 12s? I really hope so. We can move on to the next principle. So the next principle has got what are known as tangents. Ever heard of tangents? Well, when we are talking of tangents, we are simply talking of a line that touches a circle at a certain point. Only one certain point. Can you see that line? Can you see the circle? So imagine we've got our center of the circle there, and then we've got a line coming from the center of the circle. I don't know, I'm using that funny line, but we've got a line coming from the center of the circle going directly to a tangent, touching a tangent at that point is the center of the circle O. So the angle formed by a tangent and a radius of the circle touching the tangent, or rather this line is known as a normal in this case. This angle between the tangent and the radius is always 90 degrees. It is always 90 degrees. Understood, grade 12? It's always 90 degrees. Very easy concept. Very easy to grasp. Angle between the tangent and the radius is always 90 degrees. Okay, we can move on to another concept, and this one is dealing with the same cyclic quadrilaterals. It's also very easy to grasp. Let's say we've got a cyclic quadrilateral. A cyclic quadrilateral. Okay, so based on the previous concept that we just went through, let's say it is A, this is B, this is C, and this is D. We said opposite angles are equal to 180, so B plus D equals 180, A plus C equals to 180, and in this case we've got another point D. Now if you've noticed, line BC extends up to D. It's gone out of the, it's gone past past the circle. So we can find angle C by saying 180 minus A. We can find angle D by saying 180 minus B, because we're saying angle A is equal to, or rather, angle A plus angle C is equal to 180 degrees. Remember, yeah, they are opposite each other, so A plus C is equal to 180 degrees. Then angle B plus angle D equals to 180 as well, since they are opposite each other, right? We can find this other angle, which is angle DC. DC is supposed to be E. DCE. How do you find this angle? Well, you know that a straight line adds up to 180 degrees, right? 180 degrees. So if we remove part of a straight line, what we remain with, let's say this is x, what we remain with the other side is 180 minus x. Am I right? Because we've removed x from 180, so the remaining part is 180 minus x is an 8. So similarly, when we have such looking figure, and we are asked to find sorry, let me just get rid of that, and let's say we are asked to find angle DCE. Let's say we are asked to find angle DCE. Okay, just made things worse. Okay, anyways, let's say we've been asked to find angle DCE. We've been asked to find angle DCE. Let's name it as x, and we've been given this angle A to be 110 degrees. How do you find angle DCE? How do you find x? Well, we know that A plus C should give us 180 degrees. So to find this angle here, we are simply going to say A plus C is equal to 180 degrees. Angle A plus angle C equals 180 degrees. We have our angle A to be equal to 110, so we have 110 plus C is equal to 180 degrees, right? So angle C is equal to 180 minus 110, right? So angle C is therefore equal to 70 degrees. Yes, you're right. So we have 70 degrees there. How do you find this other angle there how do you find angle x? Well, we know this is a straight line and we removed 70 degrees. So angle x is simply equal to 180 minus 70 degrees. 180 minus 70 gives you 110. So the key thing that we have to remember is when you have a cyclic quadrilateral and one part of it extends far beyond the circle, the angle outside the circle is always equal to the angle opposite the angle inside. So if this is 110, it means this is 110. Similarly, if this Similarly, if this is D, it means this is also D. And if this is B, it means this one is also B. Okay, so now let's have a quick recap of all the principles that we've learned. We've learned of angles in a triangle. We've said angles in a triangle add up to 180 degrees. Angles in a triangle add up to 180 degrees. We've learned that when you've got a cyclic, we've got a circle and you've got the center of the circle, and then you've got a triangle being formed with two lines joining at the center of the circle. The other two are joining at the circumference of the circle. We said the angles at the circumference of the circle are equal, right? They are both the same. And when you've got two angles, one being formed at the center of the circle, the other being formed at the circumference of the circle, we said the angle at the circumference of the circle is half the angle at the center of the circle. We've done so many things with talks, and I really encourage you to look forward to our next video. In the next video, we'll be looking at past examination questions on the circle theorem, and we'll try to understand more by practicing. So this was just me giving a summary of circle theorem, and I hope you will join us in our next video. In the next video, we'll look at practical examples, practical questions that will help us gain a better understanding on the circle theorem. Thank you very much, creators, for tuning in, and see you in the next video.